Hello, everybody. My name is Benny Tritsch, and well, I'm part of Rex Analytics, and I also work for ControlUp 3 days a week. I work as a pre-sales engineer at ControlUp, and that's what I do. Okay, Rody, short intro.
Yeah. So I'm Rody. I'm a consultant at PQR, working mostly with workspace environments. So that's me. Quick and short.
Alrighty. So we want to discuss why GPUs really matter in EUC environments, because we get this question quite a lot that people ask, really, why do the GPUs matter? Can we not do it with CPUs alone? Why would I want to use the GPUs? And this is how the EUC user sees the world, because the EUC user, when he looks at himself, says, yeah, hey, that's me. I have access to a EUC environment that may be GPU accelerated or not. And you see there's a whole range of offerings that they can use, all the different offerings that you see from the cloud and on-prem. And there's a remoting protocol between the endpoint of the end user and, well, the host. But the thing is that next to the primary user, you also have the other users, the noisy neighbors. And the problem is that the noisy neighbors generate a lot of additional load on the machines, and so they're consuming the resources that the primary user thinks he has access to. And this degrades the user experience, and this is one of the things that you can compensate with GPUs, because what you do is you have the CPU, and the CPU still runs most of the code, even if there is a GPU. But for very compute intensive functions, the CPU can offload the code to the GPU. The GPU is optimized to run this compute intensive functions, typically by parallelizing them. And computer graphics is particularly well suited for exactly that. And the other thing that you can do with it is video encoding and decoding. So you really want to offload that kind of functions to the GPU, because the GPU has many similar elements, components that can do a lot of stuff in parallel, what the CPU cannot do in the same way. So, like I said, the GPU benefits for the remoting are, number one, the hardware accelerated video encode and decode. When you're using video playback software or video encoding software, like you are using a video creation software, that is one of the things where GPUs really benefit the user. And the other thing is encoding the remoting protocol data stream. And Roddy will cover that in a little bit. In addition to that, well, the rendering of the graphical objects, that is something that the GPU can do particularly well. Starting with Windows Vista, Microsoft introduced a new window desktop manager that is based on DirectX, and DirectX can be a GPU accelerated. So the Windows operating system, the newer versions of the Windows operating system, they all benefit of the GPUs. Like I said, graphics API support, that is something that defines the user experience, the image quality, and the perceived multimedia performance. I picked those from this list that the GPU can leverage most. The others, like user logon time, like perceived frame rate, and all of these, those are not so much dependent on the GPU by definition. But the other three, and I will quickly focus on these three. But as a starting point, I want to take a look at the network latency and logon time. I mean, this is something that you can collect with with typical monitoring tools that are out there, tools and products that are out there in the market. Here is an example. I have ControlUp, and you see that there is like the latency, the bandwidth, and all of these metrics. They can be collected very easily by a by a monitoring tool. And you see also log-on duration is a critical factor. And this is one of the latest script-based actions that are integrated into ControlUp that allow you to analyze the time it takes a user to log on. But the problem is all these telemetry data points, they cannot help you to identify where are the problems when it comes to perceived user experience, like the graphics API support. That is one of the things. And I'm not only talking about high-end graphics, I'm also talking about Office. I'm talking about the Windows operating system, the window manager itself, the browsers, the Adobe tools. And to give you an example, what can go wrong if you don't have a GPU on board in a remoting session, I have a video. And it's like a best of video or the outtakes when we do our Rex Analytics screen recordings. And let's just run the video and take a look at what the effects are. Let's make it full screen. And the video rolls, so everything looks nice, but then, whoa, look at that. We get a fatal error. So obviously, something with the DirectX doesn't work as expected. So now we have an OpenGL application. We start the OpenGL application, and it stops immediately. And this is what you cannot see in telemetry data. Now, another one, OpenGL. We just started, and it closes without notifying the user. This is not good user experience. DirectX 9, we start a DirectX 9 application. Again, we cannot create the device interface. So these are the things that your users will see when the GPU is not available or when the soft GPU, and we will talk about soft GPU later, does not what is expected to support those graphics APIs. So here's more. And the interesting thing is, from a monitoring perspective, all the performance counters look fairly well because there's no load that's being generated by these applications. So for these admins, everything looks good. Unfortunately for the user, it doesn't. So the user sees all these error messages and is definitely not happy about what the user sees. But there's more. We have this image quality and codec artifacts. And again, we collected some of those outtakes. And let me run this video, which is very interesting. So you see there is a problem with the color lookup table. And it takes roughly 5, 6, 7 seconds until the color lookup table is updated, and then the color is correct. And we were able to reproduce that effect with different drivers, GPU drivers or no GPU. And you see this is a very old recording where we have RDP, and the water is red, then it turns black, and then finally it turns blue. So it takes a while until everything is fine. So you see, again, all these artifacts as well, that the water is not rendered in a good way. So there's clearly a lack of a GPU that does the heavy lifting. And when we're going back in time even more, you see the tiling. It's very impressive how you can watch the image when it's created with individual tiles. That was very early in the history of the RDP protocol. But this gives you an idea what things look like when they do not work as expected. And the last one that I have is another interesting effect that you can see when the video driver does not work in the way as it's supposed to be. Maybe it's hard to see through the Zoom session, but maybe you can see it that the application cannot focus. It jiggles around. And we were able to reproduce that with several GPU drivers. And sometimes we are able to see that without a GPU. From a monitoring perspective, telemetry data says everything is fine. This OpenGL application renders, but for the user, it's absolutely unusable. So this is what we mean when we say, hey, we really got to go beyond the telemetry data and take a look at what the perceived user experience is. Okay, So at this point, when my slide deck lets me move forward,
Yep.
I should be able to hand it over to Rody.
Yep.
Rody, take it away.
I will quickly share my screen. So I think you got us all a bit nauseous with that last video.
Sorry
I'm
about
still
that.
struggling to get my eyesight back. But all right, so why GPUs matter for remoting protocols? So I think Benny already gave a few hints. But first start with the remoting protocols. Why do they even use compression? Because every frame that is sent out is compressed by the encoder, and there are different encoders. But why do we compress them? So if you look at a full HD resolution, a single frame uncompressed is already 6 megabytes per frame in size. So if we run it with 30 frames per second, it means that you have almost 180 megabyte per second. So that's a quite big WAN connection you need to run that uncompressed over the internet. If we move on to 4K, it's getting even worse. A 4K image is roughly 24 megabyte per frame. So with 30 frames per second, it's more than 700 megabyte per second. With 60 frames per second, it's even more insane. So it's 1.4 gigabyte per second, which means that I think even with a 10 gigabit connection, you can't run it uncompressed. So that's why we use compression. So do I need a GPU for compression? I have a quick demo where we compare a YouTube video in a CPU-only scenario versus a GPU-powered scenario. And you will see that even though we don't have a GPU, let me see if it starts running. No, yep. Even though we don't have a GPU, it's working quite okay. So I was really impressed with this result. And Benny and I talked about it before, and yeah, we think that the CPU now has some optimizations to run these codecs, but as you can see, the red result, the CPU is going through the roof, 100% CPU usage. But hey, yeah, the user experience is okay, but you can't run any other app next to it. So this is a 4K VP9 YouTube video, decoded on the CPU on the left hand and decoded on the GPU on the right hand, and published to a full HD resolution monitor. So I think if you run a 4K monitor, you won't have this user experience, but you can clearly see that the decoder and the encoder is used quite heavily. So heavily, 10%, 5 to 10% decoding time, and for the encoder around 5 to 10% as well. So yeah, you can see that you can run it without a GPU, but it's better with. Let me check because I think yep, there we go. So why do we need a video codec? As you saw in the previous video, is that you have many frames per second. And to do a good quality over a low bandwidth connection, you need compression. Compression with a PNG or a JPEG encoder for moving images isn't that great. So I did a size comparison between a JPEG, so a screenshot of a website, and I also took a 5-second movie screen capture with 30 frames per second. So it's 150 frames. And you can see in the right hand the web page I used, tweakers.net. And the PNG, so uncompressed still image, is around 900 kilobytes. The JPEG is 450 kilobytes in size. And the H.264 video is around 400 kilobytes. So for 150 frames, I only need 400 kilobytes. So it's quite some magic they do with video codecs. So you can imagine if you have a video stream and you encode it with JPEG, you need more bandwidth than H.264. And to show you the difference, I created a comparison. So the thin wire encoder on the left, which uses a JPEG encoding or PNG encoding, and a video codec on the right. And you can clearly see a difference here. So both are backed by a GPU to render the image in the VM, but from the VM to the client is utilizing the CPU on the left-hand side with JPEG encoding, and H.264 with NVIDIA encoding on the right-hand side. And you can clearly see there's a massive improvement in user experience there. So let's take a look at the different encoders then in comparison with GPUs. So Citrix has many different encoders. So thin wire using JPEG, adaptive display, active changing regions, it's also called, or H.264, H.265. And if we look at the GPU-powered encoders, then you can see that most of the encoders can be supported by a GPU or offloaded to a GPU, which will enhance the user experience. If we look at VMware with Blast Extreme, then you can still see that most of the encoders can be supported by GPU. Unfortunately, the encoder switch, the VMware version for active changing regions, currently doesn't support the NVENC, so I hope that they will add that in the future as well. For Rubens, SciFrame is also mostly backed by a GPU if you use Google Chrome. If you use Mozilla Firefox, it's using CPU only. And you can do H.264 there as well. So as a conclusion, we can see that the GPUs enhance the remote user experience in an EUC environment. And we can offload tasks from the CPU, so rendering task or protocol encoding to the GPU, which will lower the CPU usage in your environment. So that's why GPUs matter.
Yeah, the thing is that all the vendors are working on that. All the EUC vendors, they are working on using the GPUs more and more. And this is the good news. So I would predict that in a couple of years from now, there will be no discussion if we want to have GPUs in a VM or not. There will all be GPU powered. Yeah, it's only a matter of time until we get there. We have the same happening on laptops. Today, you cannot buy a laptop without a GPU. And I believe the same is going to be true for any desktop as a service, that they will all be GPU powered.
Yeah.
Okay, that brings us to the last slide. We need GPUs for the speed to have beautiful rendering and to encode those images so efficiently that we can really see it, and the perceived user experience is great because this is what users want.
Yeah. So for the Command and Conquer fans, left side, the old interface, right side, the new rendered one. Don't try that without a GPU. It will break.
Okay, with that,
thanks. That's
we are done. I hope you learned something, why you really need a GPU.